Good morning, everyone. I hope you all are sleeping. Anyways, welcome to a trig video. So first thing we're gonna go over is SOH CAH TOA, the acronym SOH CAH TOA, and it basically means it helps us remember that sine theta is opposite over hypotenuse. Cosine theta is adjacent over hypotenuse. Tan theta is opposite over adjacent. So opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. And then the reciprocals of these for sine is cosecant, reciprocal of cosine theta is secant, and then reciprocal of tan is cotangent. So to find those, you would just switch them. And for these three, sine, cosine, tangent, and then the reciprocals, the only one that we know, like the actual value of, is 0, 30, 45, 60, and 90 degrees. So the special right triangles, there are two. So it's the 30, wait, yeah, okay, that's not very accurate, but 30, 60, 90, and then 45, 45, 90. Okay, so how I remember it is, if we're using numerical values, it would be, for this one, it would be 1/2, 1, and then square root of 3 over 2. But I remember it as 2a, and then a square root of 3, or a rad 3. And then for the 45, 45, 90, a, and then a square root of 2. And for numerical, square root of 2 over 2, square root of 2 over 2, and then 1. So basically, for example, we're going to do, say, sine 45. So sine 45, so sine is opposite over hypotenuse. So we're looking at the 45-degree side, or like this one, and you take the opposite. So this one is opposite of this angle because it's like across. So you take this and you put it over the hypotenuse, and the hypotenuse is 1. And so sine 45, this is sine 45, sine 45 degrees, is just square root of 2 over 2. And then cosine 45, so cosine is here, or the angle is there, 45 is there, and you have adjacent over hypotenuse. So adjacent, this one is adjacent, and this is hypotenuse, so it's the same thing. Okay, and then tan 45 is opposite over adjacent. So opposite here over adjacent here, and that would just give us 1. So tan 45 is 1. And then when you flip these, you would find the reciprocal of all these would give you cosecant, secant, and cotangent. Yeah, so I'm gonna write all of them. There's a way I used, actually it's not really, well, I don't know if it's an actual method. This is how I remember it. we have sine and then we have cosine. And then tan is just separate. And you can just find tan by doing sine over cosine. Yeah, so it's just important that we remember sine and cosine, because from there we can find tangent. Yeah. So what I do is I write 0, 30, 45, 60, and 90. And then I go like the other way. So I go 90, 60, 45, 30, and then 0. And like, so 0 plus 90 is 90. All of these, when you add them, they all equal 90. So they're all 90, 90. Yeah. Okay. So, oops. And then the values in the middle. So these values, I just remember them. But yeah, we'll apply these later. So basically what this means is sine 0 and cosine 90 is 0. Sine 30 for like sine 30 degrees, and cosine 60 is 1/2. Sine 45 and cosine 45 is that. Yeah, that's how I remember it, because I don't want to do the math every time. And then tan, you just put them over each other, but for now I'm just gonna write them out. So tan 0, 30, 45, 60, 90. These are all degrees. And you get 0 square root of 3 over 3, 1 square root of 3, and then you have undefined for tan 90. Yeah. Okay. So now, where's my thing? Okay. So when we have, let's say, the question or the directions said find the value of each trigonometric ratio. Okay, so, and then they give us a triangle, and it says 50, 40. Shout out to my math teacher, because I take this from classwork. Yeah. And then it said find, what they give us to find is cosine C. So what I do first, oh wait, wait, hold on, this wasn't here yet. Okay, so what I do is they're asking for cosine C, so I draw this angle on C so that it's easier to identify what we need to find. So cosine we know is cosine of theta, which in this case is C. So cosine C is adjacent over hypotenuse, because SOH CAH TOA, so yeah, I'm gonna write it out. So you go adjacent over hypotenuse, right? So that's just 40 over 50, which just simplifies to 4 over 5. So that's simple. But what if we had to find side lengths? Should we do side lengths? Actually, okay, we'll do side lengths after. Okay, so another question asked to find the measure of the indicated angle to the nearest degree. Okay, so we're given this triangle. The hypotenuse has a side length of 45. This is 29, and they're asking for this angle, and this is a right triangle. So we're gonna use what they gave us. So they gave us this length and this length. So they gave us, according to this angle, they gave us the opposite, right? And then they gave us the hypotenuse. So which ratio has to do with the hypotenuse and the opposite? Cosine, right? Oh no, opposite hypotenuse, sine. So we're gonna do sine theta equals, and this angle is theta, 29 over 45. So basically, to isolate theta, we have to get rid of sine. So to get rid of sine, we multiply each side by sine inverse. So just like this, and that gets rid of sine. So now we're just left with theta equals sine -1 and then 29 over 45. And when you plug this into your calculator, we're gonna round it. So what do you get? Sine inverse times 29 over 45. So I got 40.1240, yeah. But we're gonna round it to the nearest degree. So it's just gonna be 40 degrees. Yeah, that's how you do that. And I will make a separate video for finding side length. So for example, if we're given something like this, and then we need to find, so we're only given one side length, but we need to find these two. We can find that from using the trigonometric ratios or functions of 30 degrees to be able to find what m and n is. Yeah, so that will be the next one. Yeah, bye guys.